Hi dear children, this is grade 11 chemistry topic isomerism. We know that an isomer of a molecule is a molecule with the same molecular formula but a different structural or spatial arrangement of atoms. This variation can lead to a difference in physical or chemical properties. Isomerism is the property of two or more compounds, that's called isomers, compounds that have the same molecular formula but different arrangement of atoms and hence different structural formula. This is called isomerism. And divisions of isomers or isomerisms. Isomerism in an organic compound can be classified into 5 different types that have the same different types according to the scheme. Here it is showing the picture, that is isomerism. It mainly classified into structural and stereoisomerism. The structural isomerism we have to study in this class 11, chain isomerism, positional isomerism and functional isomerism. These three we have to study now. And then stereoisomerism classified into geometric and optical. In class 11 we will study about geometric isomerism and the division of that one also. Isomers are molecules that have the same formula but different structures, and different structures change the properties. And structural isomers are joined in a different order. Stereoisomers have a different arrangement in space. Now these are the types of isomerism. Structural isomerisms classified into, this is chain isomerism, position and functional isomerism. Stereoisomerism, you have to study geometric and optical. These are the main 5 divisions of isomerisms. Now we have to discuss about the structural isomerism. Structural isomerism, that is, differs as to which atom in the molecules are bonded to which. Mainly there are 3 types of structural isomerism: the chain isomerism, positional isomers and functional isomers. Chain isomers have the same number of carbon atoms as one another, but their carbon backbones are different. Backbones are different. That is the chain isomerism. Here it is saying isomers linked. Example, butane C4H10, the 2-methyl propane. Here it is 4 carbon atoms in main chain. Here it is 3 carbon atoms. So this is the difference in the chain. So chain isomerism have the same number of carbon atoms, but their carbon backbones are different. The arrangement of carbon atom is different. And the next one is positional isomerism. But this is often included under the general umbrella of structural isomerism. That is positional isomerism. They have the same carbon backbone, but the position of their functional groups are different. Okay, here see butane 1-ol, here this butane 2-ol. Here the functional group OH group is the functional group. This is placed in a different position. It's about positional isomerism. So their systematic name reflect this. For example, there are 2 types of this is butane 1-ol and butane 2-ol. That is about positional isomerism. Next one is functional isomerism. In functional group isomerism, the isomers are more different than in the type of isomerism considered before. Okay, the compounds that contain a different functional group often have very different reactions. But here it is functional isomerism. Substance having different functional group. Example, ethanol. The alcoholic, that is OH group is there, ethanol. But here it is methanoic C, methane, C2H6O. But this way it is functional. A functional group is different. This is about the functional isomers. So structural isomerism mainly classified into chain isomers, positional isomers and functional isomers. So carbon atoms in isomers linked differently. Here it is the functional group are in different position. Here the functional groups substance are different functional group. This is about the 3 types of structural isomerism. Next one is stereoisomerism. But this stereoisomerism are very closely related to each other. They contain the same atoms bonded to one another, and the bonding and the functional groups are identical. But they differ only in the way the atoms are arranged in a three-dimensional space, that is stereo, three-dimensional space. And then there are two types of stereoisomerism, geometric and optical isomerism. Here geometric is, we have to study more about this geometric isomerism, are the stereoisomers which differ in their spatial geometry due to the restricted rotation across the double bond. These isomers are also called as cis-trans isomers. For example, the molecular formula C2H2Cl2 corresponds to the two geometric isomers, see 1,2-dichloroethene, and here this is a cis isomer. This is trans means 1,2-dichloroethene. You see, the number of atoms are all same, but here it is the hydrogen are in the same side of the double bond, but here it is this hydrogen is the or chlorine, and here it is hydrogen and chlorine at the same, hydrogen is the same side, at chlorine that is the same side of the double bond, but here it is on the opposite side, chlorine it is opposite side of the double bond of the carbon atom. Here it is the structural isomers have the same molecular formula but different arrangement of the atom in the molecule of the compound, different order of atoms are connected. Stereoisomers have both the same molecular formula and structural formula connected in the way, but they differ in the spatial arrangement of the atoms in the molecule. The cis isomer, this is same side of the double bond, but trans isomer the opposite side of the double bond. This way it is arranging in stereoisomers. Now here it is some examples of stereoisomers and geometric isomers. See, this is 2-butane, trans to butane. We had the methyl group is same side of the double bond. Here it is methyl group is opposite side of the double group. And here it is 1,2-dichloropropene, and this is 1,2-dichloropropene. Same molecular formula and structural formula, but the arrangement, the space of the functional group is, here it is the chlorine atom is same side of the double bond, chlorine atoms are in the opposite side of the double bond. This is the examples of geometric isomerism. Okay my children, I think all of you understand that.